conducting our research on designing mobile applications to minimize disorientation in informal learning environments. So different kinds of informal learning environments, or in short, ILEs, include museums, science festivals, and science centers, which attract large audiences with a common desire to learn something. And among such ILEs, science festivals have been known to provide a large variety of learning opportunities due to their transient science experience. And much like in an indoor classroom, children in ILEs may face different types of distractions which can hinder their learning performance. And these distractions lead to disorientation, which may impede an individual's learning performance. So we argue that minimizing disorientation can improve the learning experience sought during science festivals, especially through mobile technologies. And the main question guiding our research was that what are the factors which can cause disorientation while performing an educational task using mobile technologies in a science festival or in ILE, and how do learners reorient then towards the learning task? And for that, we considered the role of mobile technology, people accompanying the participant, the task length, and other environmental influences in a science festival, which appeared to be a less explored notion with respect to imparting education in an ILE. Formally, for our study, we defined disorientation in the context of ILE as any off-task behavior resulting in deviation from the intended learning goals. For the learning task, children had to use the app that we designed to watch an educational video about different types of leaves, after which they had to identify them correctly from the artificial leaves that we weaved around our exhibit. And they had to take a picture after finding that particular leaf. They had to take a picture using the mobile application. And the figure on the bottom of the screen shows the progressions within the mobile application, and we did not incorporate automatic image recognition in the app because we wanted to observe children's off-task behavior while being tolerant to their incorrect captures. And we tested this application during the Virginia Tech Science Festival in 2020. Actually 2019. We asked participants to try our mobile application crafted for performing a nature-related learning task. The Science Festival hosted about 50 exhibits that year, which attracted an audience of about 6,000 people, primarily children with their parents or adult caretakers, making it a suitable venue for exposure to informal education. For this experiment, we focused on elementary school-aged children because children in this age range could perform the activities that we wanted them to perform, which required retention of visual cues from the video and the ability to find and capture pictures using mobile phone's camera. And 44 participants aged between 5 to 10 years visited our exhibit, who were joined by their siblings, their parents, friends, or adult supervisors. And one of the researchers and a volunteer were asked to assist participants at our leaf identification exhibit. For the children who were interested in participating in the activity, a volunteer described the activity to be performed. And throughout the procedure, one researcher and volunteer were near children as minimally engaged assistants, providing guidance when asked. And then I, along with 2 volunteers at the exhibit, took extensive notes about the behaviors and attitudes of children while performing the task and their surroundings. And after the science fair, 2 of the researchers gathered to compare notes and share lessons centering around the notion of disorientation and reorientation. Prominent findings from our study were that the limitation of time versus the activity versus the duration of the activity disoriented participants fairly quickly because they wanted to fit several activities within their budgeted time. Like they had to visit all the exhibits that they had planned for the day during their time budget. And We also observed that parents were not only accompanying the children, but they were actually passive participants instead of being just onlookers in our learning activity, because their level of attention, their patience, their interest, or the lack thereof directly affected the children more than any distractor in the application or in the environment. And the majority of the parents were intervening a lot during the task because they wanted to dedicate the time to the activity for their child to learn something or have a good time, which actually ended up distracting the children. And then some participants were also distracted when like when their curiosity had the best of them, and they were trying to peek into other participants phones to see what was happening, and how were they doing with respect to other participants. And for this type of disorientation, children continued with the activity because of either parental pressure or being too courteous to leave abruptly. And also the lack of interactivity with the mobile application during the educational video urged the participants to look around to find objects of greater interest, because they apparently they found no obvious purpose of engaging with the instructional video, which was only, we trimmed down the video to 1 minute, but even then the children were being very impatient. And children also stayed quiet during the first half of the activity, which was watching the instructional video and checking out the favorite leaves. But they became immediately involved and started asking questions from the researcher and the volunteers or their parents or group partners when they felt challenged or responsible for performing an activity on their own. And also, we noticed that having minimal controls in the application made it easy for children to navigate the task in the science festival, because they had a lot of cognitive distractors in the environment. We also had like in half of the versions of the application, we had 8 phones, and in 4 phones we had designed a progress bar, which showed children how much of the task was remaining. Our intuition was that it would help the children to reorient towards the task, but that was not the case. They did not seem to notice that there was a progress bar in the application or what its purpose was. And based on our findings, we suggested some design implications for educational mobile applications for children. We found in our observations that not only peers, but parents were highly interested in interacting with the children during the learning task. But this phenomena was not observed with children who came with the teachers or other adult chaperones, such as teachers, probably because there was a greater level of comfort between the family members. And therefore, considering the supervisory role of parents in children's activities in ILEs such as Science Festival, we encourage designing collaborative technologies for parents and children, as they can pivot parents' attentions toward the task that they have to perform, subsequently minimizing the child's disorientation. And based on our observations, visitors of science fair are looking for opportunities of education, as well as activities that stimulate scientific inquiry. So educational applications should strike a balance between incorporating elements of entertainment and learning, so they can engage and orient participants for a longer time. It is also important for child-oriented educational applications to reduce navigational choices for children to help them focus on the learning task. Additionally, as I talked about the time budget, so considering time as a constraint while learning in an ILE puts an emphasis on designing shorter and more engaging instructional content. And we also noticed that elements of reflection, which can nurture the natural tendency of children to see how well they do with respect to others, seem to be a desirable element in an educational mobile application. And also because learners are on a time budget while performing activities in an ILE, educational learning applications should be able to provide immediate feedback and reward to the children to help them stay focused on the task. Results from this exploratory event provide baseline understanding of factors that can cause disorientation and how learners reorient towards the task during the learning activities, which can inform the design of educational mobile applications for use in ILE to provide a learning experience while minimizing disorientation. And our findings are also arguably applicable to learning in semi-controlled outdoor environments and outdoor play pervasive learning environments. And a possible direction of research followed by our work is to survey the use of mobile technologies for imparting education in different types of ILEs other than the science festival, such as museums, to study if the effects of disorientation remain consistent among different age groups and for different environmental contexts. I also want to share a fun fact that this paper received 4 rejections in the year 2020 before finally being accepted at 2021 ACM Interaction Design and Children Conference, where it also received an honorable mention award for short papers. I am presenting this work on behalf of the co-authors of this paper, Morva Sati and Dr. Scott McKickert. And Morva is here in the session, and we now look forward to any questions, comments, or suggestions that you may have.